So this one is a classified paper related to topic for electricity and magnetism. The first one, electrical energy produced by the power station is transmitted over long distances at a very high voltage. Explain why a very high voltage is used. What is the reason why we use a high voltage? You can annotate on the screen. You can also use your mic or a chat to answer. So when we use a high voltage, basically which transformer is used? We use a step-up transformer. First thing, when we use a step-up transformer, uh, you cannot mention so decrease resistance. That point you cannot mention. First thing, when we use a step-up transformer, the step-up transformer increases the voltage, so it reduces the current. When it reduces the current, what is the effect of the current? Current can produce heat, magnetic field, and chemical changes. So if the current is reduced, so what will happen? The heat loss, the amount of heat produced in the wire will also decrease. Another thing, because we want to transfer a smaller current. So if we want to transfer a smaller current, what we can use thin wires. Because if we want to transfer large current, we use thick wires. For a smaller current, we use thin wires. And thin wires we can use for this transmission. Another thing, what is the advantage of using a thin wire? Because it will cost less. Another thing of using a thin wires, we can use a cheaper pylons. The thin wires are carrying the same current. And another thing, because thin wires are there, so as a result of a thin wire, we can use a cheaper pylons for the support. Pylons are height extension wires. The pylons are there which are supporting these wires. So cheaper pylons can be used as well. So you have to relate them, like first mentioning step up transformer, increase voltage, reduce current. Less current means less heating effect. Less current means thinner wires can be used for transmission, which reduces the cost. And thinner wires will have less weight, so cheaper pylons can be used to support them. Figure 10.1 represent a transformer. You can see P and S are the, so this is a transformer. Here, number of turns of secondary we need. What is the formula for the transformer? So we have, so Vs over Vp is equals to Ns over Np. So this one is Vp, which is 120. This one is Vs, which is 9. Number of turns of primary Np and number of turns of secondary we don't know. So Vs, which is 9 over Vp, which is 120. Ns we are finding and Np is 4000. By looking at this transformer, which transformer is this? Step up or step down? Step down, because it's obvious like it is reducing a voltage, so it is a step up, a step down transformer. And so, and you can see from number of turns of primary are more as compared to that of secondary. That's why it is also a step down. Final answer is 300. So 300, but don't write the unit here because turn, it's a number. Number does not have a unit. Like refractive index also does not have a unit because it's a ratio. Name a suitable material for the core of the transformer. Which material can be used to for the, so iron you can mention, or you can mention soft iron. Soft is refers to a term which is can be easily magnetized and demagnetized. That's why we saw, because different types of irons are there in terms of the percentage of the carbon. So we use a soft iron which is highly malleable and can be easily magnetized. Another question, figure 8.1 shows a circuit. As you can see, a circuit is there, an ammeter, a resistance wire, which is 6 ohm, having a length of 2 meter, another 2 ohm, and then 3 ohm. The lamp has a resistance of a 3 ohm, and the line XY represent a uniform resistance wire of 6 ohm. Calculate the reading on ammeter. Reading on ammeter means we need the total current in the circuit. Like this is our circuit. So if we need the reading on ammeter, what is the formula? The current is V equals IR. So current is voltage divided by resistance. What is the total voltage? 12. And what about the total resistance of a circuit? 6 ohm, 2 ohms and 3 ohm, they are connected in series in one line. So 6 plus 2 makes 8 and 8 plus 3 makes 11. So this will be 11. So 12 divided by 11, 1.09 ampere. Clear this part? Now, figure 8.2 shows a circuit with a different connection to the resistance Y and added resistor. The length XY of the whole resistance wire is 2 meters. The contact is made at Q where the distance is only 0.6 meter. Calculate the resistance of the circuit. Now, how to work out the resistance of a circuit? First, how these two are connected, these two parts in parallel. So they are in parallel. And then after finding the combine of these two parallel, and then we'll just add, we'll get the total resistance. But before getting it parallel, this length is 0.6. In the beginning of the question, the first part they mentioned, when this wire was having a length of 2 meter, it was 6 ohm. So we know resistance and length are directly proportional. So if 2 meter is having a resistance of 6 ohms. So if we have a wire of 0.6 meter, how much is the resistance? X. Because they are directly proportional, so we can just simply cross multiply. If resist length increase, resistance increase. If a length decrease, resistance will decrease. So it will be 3.6 divided by 2, because 0.6 into 6, 3.6 divided by 2, that will be 1.8 ohm. 0.6 into 6, and then divided by 2. So 1.8 ohm. Now, this resistance is 1.8. These two are in parallel. So if these two are in parallel, how we work out the combined resistance? So it will be product divided by sum. So 1.8 multiplied by 1.5, the product, divided by sum 1.8 plus 1.5. What is the answer? 0.82. 1.8 into 1.5 divided by, and the combined resistance should be smaller than the smallest one in the combination. So 0.82 is a combined. So this whole resistance is 0.82. So 0.82 plus 2 plus 3. What will be the final resistance of the circuit? So we just add, so it will be 5.82 ohm. So using the ratio, we work out the resistance of this section of the wire, because the total 2 meter was having 6 ohm, but zero point 0.6 will have less than 2 ohm. So that was 1.8. And these two are in parallel. So we work out product divided by sum. And to get the total resistance, we simply add them. Okay? Anyone having a doubt in this? Any question or a doubt? Sorry. 4.2 to 4. Electricity question. Figure 10.1 is a simplified top view of a flat coil. There is an AC current, alternating current in the coil. Describe the magnetic effect of this alternating current. What is the effect of, if we have an AC current, how it will affect the magnetic pattern? It will change. Two things will happen. It will change the direction, and it will change the magnitude of the magnetic field. Because that's how that's what happened in alternating current. It decrease the magnitude. So the direction strength of a magnetic field will also increase or decrease. And because it is positive and negative, means the direction is changing. So when it is like plus 3 volts, the magnetic field poles will be different. When it is negative minus 3 volts, it will be opposite. So it will change change the poles polarities of the magnetic field, and as well as the strength. Both will change. Then figure 10.2 shows the pan which is placed on the coil. The base of a pan is made of steel. State the quantity is induced in the base of the pan. Which quantity is induced? Like produce. When there's, so it will be electromotive force or EMF. Because this is a change in magnetic field. So a change in magnetic field induce EMF, or you can also say current. The pan contain the water. State and explain. No, the question, no, induction is actually a production. So you cannot say induction is produced. Induction is produced does not make sense. Electromagnetic induction produces EMF or a current. And what is electromagnetic induction? Because there's a continuous change in a magnetic field, that's why in the pan there will be a current, or there will be a potential difference or a voltage or EMF. The pan contains water. State and explain the effect of the quantity induced on the temperature of a water. First, for example, you write EMF or you wrote current. What is the effect of current? So current will produce heat because current is having a heating effect. And that heat will transfer to the water. By what method the heat transfer from the pan to the water? Which method? Conduction. Because whenever two different surfaces are or materials are there, it is by conduction. So it increases the temperature because the heat current produces heat, and heat is transferred by conduction from pan to the water. And what is the effect? Look, what is the effect of the diameter or the radius on the